Okay, so I wanted to make this video, and just one thing so you guys know, I'm kind of doing this in reverse order. I'm going to do section 4.3 before section 4.2, just because I think that'll work better. And ultimately, we'll kind of go back and forth between 4.3 and 4.2, because I think it works better as far as how we want to define all the material we're going to cover. So what we want to go over today is, we're going to start looking at right triangles. And we all know what a right triangle is. Draw it nice and big, and that's a 90-degree angle. And we all know the Pythagorean theorem, a squared plus b squared equals c squared. But now what we want to do is define new functions on that right triangle, and they're called trigonometric functions. And there are actually 6 of these we're going to use in this class, but for right now we're going to focus on 3 of them. Sine, cosine, and tangent. And we define these functions on a given angle, and the angle matters. So for the sake of argument, we're going to say this is theta right here. That's a Greek letter theta, and that's my angle. Then I can find sine of theta, cosine of theta, and tangent of theta. And by definition, sine of theta is equal to the opposite side, we'll say O for opposite, over the hypotenuse of the right triangle. We'll do an example of this in a second to make it more clear. Cosine of theta is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent. So just so we're clear, if this is my theta right here, the side opposite theta, the side theta's angle opens to, is considered opposite, the O here. The side next to theta that isn't the hypotenuse is called the adjacent side, and then obviously we all know what the hypotenuse is right here. So once we know the sides of the triangle, we can find our sine, cosine, and tangent of that angle by just finding the ratio of the opposite to the hypotenuse, the adjacent to the hypotenuse, and the opposite to the adjacent. One other thing to keep in mind, if instead of using this angle, we use this angle, we'll call it tau right there, then sine of tau, this will be opposite, this will be adjacent. So where your angle is determines what's opposite and what's adjacent. Just keep that in mind as we start solving problems. So for now, suppose we have this, and we'll say that this side is 3 and this side is 4. Now we want to find sine, cosine, and tangent of that triangle. Before we can do that, we need to know all 3 sides of the triangle. But this is a right triangle. Since I know 2 sides, I can use the Pythagorean theorem. 3 squared plus 4 squared equals c squared. So I get 9 plus 16 equals c squared. 25 equals c squared. So c is equal to 5. So this side has to be 5. And now to find my trig values, well, let's see. Sine is opposite over hypotenuse. That's 4 over 5. So sine is 4 over 5. Cosine is adjacent over hypotenuse, so that's 3 over 5. Tangent is opposite over adjacent, so it's 4 over 3. And there we go. There are my trig ratios right there. Ultimately, you have to understand what sine, cosine, and tangent are, meaning sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. How you choose to remember that is up to you. We're going to be using it a lot, which means you need to quickly remember what's the definition of sine and cosine and so on. I'm going to have you filling out some worksheets and doing homework where you work with that over and over and over to help you practice it. One kind of standard mnemonic device that people use is SOHCAHTOA. And the idea is SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So in a lot of these videos when we're working on trig, you'll hear me say, oh, SOHCAHTOA, so it's sine over opposite over hypotenuse or something like that. Whatever you use to help you remember it is fine. You just need something to help you remember it. So, to do a couple of examples really quickly. Suppose I have this triangle right here. We'll just make it up. There's my right angle. Here's my theta. And suppose I have, this is 6, that's 9, and I don't know what that side is. Call it x. Find sine of theta, cosine of theta, and tangent of theta. Again, the first step, since I only have two sides of the triangle, is to find the third side. So the Pythagorean theorem says what? 6 squared plus 9 squared equals x squared. So that's 36 plus 81 equals x squared. Let's see, 6 and 1 is 7, 8 and 3 is 11. So 117 equals x squared. So then x has to equal the square root of 117. It's not a nice number, but oh well. I have mentioned before, there's a difference between finding an exact answer to a problem and finding an estimation of it. If this was a word problem, then we could just throw that into our calculator, round it off. It's between 10 and 11, it's almost 11. Use the decimal approximation and get a numerical answer to a problem. For problems in general, just finding the trig functions, leave it exact. Just use root 117, leave it like that, don't bother with your calculator. But now, let's see, if I want to find sine of theta is opposite over hypotenuse, so it's 9 over the square root of 117. Cosine is adjacent over hypotenuse, so it's 6 over the square root of 117. Tangent is opposite over adjacent, so it's 9 over 6, which reduces to 3 over 2. And there we go, nice and simple. One thing I'll point out, technically these are correct, but in terms of form and the way we write things in math, we don't like leaving our answer with a radical in the denominator. So you have to do what's called rationalizing the denominator. So for the sake of this one, if we look at sine, we have 9 all over the square root of 117. To rationalize the denominator, if you don't remember it from algebra, you just multiply by that radical on the bottom, because then you're squaring the radical, which will cancel out. But we know from regular rules of fractions, the only way to keep this equal is if I multiply by root 17 on top as well. Now on top I get 9 times the square root of 117. On the bottom, the square roots cancel and I just get 117. So this becomes 9 all over 117, and we multiply by the root 117 on top. And there we go. We would do the same thing for cosine, since it's over root 117, using the idea from here. If I multiply by the square root of 17 on top and bottom, this will become 6 times the square root of 117, all over 117. And there we go. Ultimately, it doesn't matter which way you write your answer, they're the same value, but for form's sake, we're going to want to write them this way. So when you do homework, I am going to mark it wrong if you don't do it this way, if you don't rationalize your denominators. Just because for form's sake, that's the way we do it. The last thing I wanted to do to kind of tie this together and see how we use it. Applications. So, suppose we say this, standard problem. I am 100 feet from a building. My angle of elevation to the top of the building is 40 degrees. How tall is the building? The first thing you want to do for this and for a lot of problems we do in this class, draw a picture. So let's see. Here's the building right here. Doesn't have to be perfect. And we'll say I'm standing right over here. finding your angle of elevation. In case you don't know, angle of elevation is the angle going up from the horizontal. Meaning, this is the horizontal line. An angle of elevation is the angle you get when you go up from there. You can also have what's called an angle of depression. That's when you start with the horizontal and you go down. So an angle of elevation goes up, angle of depression goes down from the horizontal. So for the purposes of this, I'm told my angle of elevation is 40 degrees. Normally, we would do it from line of sight right up here, which would be off the ground. For the purposes of this problem, we're not going to. We can alter it if we wanted to. We'll just say my angle of elevation is from the ground. So the angle starts here, and it goes up to the top of the building. And that angle is 40 degrees. I'm 100 feet from the building, so this distance is 100. How tall is the building? That's the height over here, x. And we want to solve that out. And if we look at it really quickly, well, all I really drew is a right triangle right here. And I can just use my trig to solve this since it's a right triangle. All we need to do is figure out what trig function relates this angle to this side and this side. If that's the angle, this is opposite, that's adjacent, so I use tangent, opposite over adjacent. I get tan of 40 degrees equals the opposite, which is x, over the adjacent, which is 100. Now just do algebra. I want to solve for x, so I multiply by 100. And I get 100 times tan of 40 degrees equals x. Throw that into your calculator and get the answer. It'll be a decimal, round it off to one decimal place, and we're good to go. I'm not going to do that here because I want you to run your calculator on your own. But ultimately, really quickly, just to finish this off, if we understand how these things work, it goes a long way towards telling you if the answer that you get in your calculator is actually the correct answer and you didn't just hit the wrong button or something. If you think about it, tangent is the ratio of opposite to adjacent, which is essentially the vertical to the horizontal. At a 45-degree angle, well, the horizontal and the vertical would be the exact same, which means tangent should be 1. You can plug it into your calculator, and it is. Because 45-degree angle would make this triangle isosceles, so these sides would be the same, a horizontal and vertical would be the same. So now, if it's a 40-degree angle, what does that mean? Essentially, if you think about looking at something, a 45-degree angle, I'd be looking at the same vertical distance as horizontal distance. If I'm at a 40-degree angle, it means I'm looking slightly lower, which means I'm looking further away than I am looking up, because my vision is a little bit flatter. Which means logically, if this is a 40-degree angle, then the horizontal distance I'm looking should be smaller than the vertical distance I'm looking at. Which means whatever x is, it should be less than 100, because that's the horizontal. So now, plug it into your calculator, make sure your calculator is set to degrees, and whatever this is, it's got to be less than 100. So you can kind of use that as a check and a guide, plug it in for yourself, and see if you get less than 100.